Hello, College Algebra. This is section 2.1. This whole chapter is going to be about graphing and some functions. And this is what we start out with is rectangular coordinates and graphs. So we're going to be looking at some pretty basic stuff starting out here. Ordered pairs, what is an ordered pair, and the rectangular coordinate system. And some of these things you may have seen in geometry, like the distance and midpoint formula, but you probably haven't applied it like we're going to apply it in this today. And then lastly, we're going to look at graphing equations in two variables. Okay, let's get started. So an ordered pair consists of two components written inside parentheses. So y'all should know that. We have a coordinate for the x and the y, and that's how it's going to be written. So here's the rectangular coordinate system. You might want to get yourself familiar what each quadrant name is. It goes from being quadrant 1, 2, 3, 4. It goes in a counterclockwise motion. I say get familiar with this now because if you're going to be joining me in trig next semester, then you'll need to know these. Okay, so we start out with the distance formula. In these notes, it shows us how the distance formula comes about using an example here. So using the coordinates of ordered pairs, we can find the distance between any 2 points in a plane. So let's look at the horizontal side of a triangle has the length. So this side of the triangle right here has the length this. We can easily calculate that because it's just a horizontal line. It's the absolute value of our x values. Okay? And then that's our distance. Then the vertical side of the triangle has this length right here to here. So we take the absolute value of subtracting our y values, and we come up with this right here. And then, by the Pythagorean theorem, because this is a right triangle, we can come up with the distance of PR. We ended up with 12 for our horizontal length, 5 for our vertical length. So, remember, Pythagorean theorem is a squared plus b squared equals c squared. And what we're finding here is the distance of C. So that is using this Pythagorean theorem in order to find the distance between two different points. So here we got 13. 13 is our distance of PR. Okay, so let's look at this. So in that example, it kind of took you steps through of how this distance formula came about, and this is the general form of this distance formula right here. So in combination of finding the vertical and the horizontal of our distances, we can use the Pythagorean theorem to help us in figuring out what the distance between any 2 points are. So let's do this. Let's find the distance between P and Q. And these are our coordinates 3, -5, and -2, 8. Let's just apply that formula. That is just the fancy way we denote distance between P and Q. And remember, it is your x1 minus x2 squared plus y1 plus y2 squared. All right. I'm going to fix that y. All right. So using this, I'm going to say this is my x1, y1. This is my x2, y2, and plug away. Okay, so let's do that. We got a 3, and then a minus -2, so plus 2, and a -5 minus 8. Now we get 3 plus 2, that's 5, and square it, we get 25. And then the 8 minus -5 minus 8, we get a 13, that squared is 169. Add those together, we get square root of 194, and you can approximate this to find about the approximate distance, but this is it in exact form. Many times that's what I'll be asking you for, is the exact form of the distance. All right, so let's look at another example. Well, before we do that, let's look at this. It says, if the sides of A, B, and C of a triangle satisfy a squared plus b squared equals c squared, the Pythagorean, then the triangle is a right triangle with legs having lengths AB and the hypotenuse having length C. So, meaning if these two squared added together equals this, if that equation is satisfied, then our triangle that we are looking at is a right triangle. That's what our next example is about. Okay, so what we're going to do is determine, is this triangle a right triangle, having these 3 different vertices that we have. Okay? You can probably look at it and tell, but not quite. This almost right here looks like a right angle, but we're not going to say it is. We're going to figure it out. Okay, so let's find the distance between all 3 of our points, well, all 3 of our vertices. So let's do that. Let's find distance between R and S, which is 5 minus 0 squared, then a 1 minus -2 squared. That ends up being 25 plus 9, which equals square root of 34. So there's the distance between R and S. Now we're going to find the distance between the other 2 vertices. Let's look at distance between R and T. And then the distance between S and T. So we get 4 minus 0. And let's see, what else do we get? 3 minus -2. So 3 plus 2 squared. Square those values, you get 16 and 25, which is the square root of 41. So there's another distance, the last one we need to find. Let's do it. So -4 minus 5, that's squared, plus, let's see, 3 minus 1 squared. So -4 minus 5, that's 9 squared, 81. And plus 4 equals square root 85. Okay, so now we're going to apply that Pythagorean theorem to these distances that we have. Okay, so we got 41, or square root of 41, square root of 85, and also the square root of 34 from the previous page. Okay, so applying our Pythagorean theorem, I'm going to remind us of our distances first. So we have distance between R and S was the square root of 34. Distance between R and T was 41, or the square root of 41. And then the distance between S and T was square root 85. Now, applying the Pythagorean theorem, I'm going to say this squared plus this squared equals that squared. Let's see, 41. Which I can tell 34 plus 41 does not equal 85. So here, this tells us that the triangle formed by these 3 points, sorry about that, this does not create a right triangle. Not a right triangle. Okay? Okay, in the next example, what we're going to do is tell if 3 points are collinear, and the distance formula is going to take play in this too. So to do this, to say if all 3 points are in a straight line, which means collinear, we're going to say the 3 points are collinear if, and I'm reading this right here, the sum of the distances between the 2 pairs of points is equal to the distance between the remaining pair of points. So if we have a line something like this right here, say A, B, C, we're going to say, remember the segment addition postulate if you were with me in geometry? That applies here. So the distance of AB plus BC is equal to AC. So if this statement right here is true, then all 3 points are collinear. Alright, so for this example, we're going to apply that, what we just saw on the previous page. And so we start out with, it's asking us, are these 3 points here collinear? And I've broken it down into parts for you. So we're going to figure out the distance between A and B using that distance formula. So the square root of our x values, so negative 2 minus 0 squared plus 5 minus 3. I don't know why it's drawing straight lines whenever I'm drawing a curve. But anyway, here we go. That is equal to square root of 8, which can be reduced. There we go. I'll do the same thing for the distance between B and C. And we have 8 minus 0 squared plus negative 5 minus 3 squared. So we got 64 plus 64 is 128, which equals 8 square root of 2. Alright, next one, we're going to figure that out, the distance between A and C. Okay. Okay, here we go. We got negative 2 minus 8 squared and 5 minus negative 5 squared. And that equals square root of 200, which is 10 square root 2. Now applying that theorem that AB plus BC equals AC, we have the, let's see, what was it, 2 square root of 2? Yeah, 2 square root of 2. Erase that. and then 8 square root 2, and that does equal 10 square root of 2. So this statement here is true, which means we have 3 collinear points. All right, something else we learned from geometry, the midpoint formula, which is right here. I really have no clever way of showing you how this midpoint formula came about, except maybe telling you that here's one good way of looking at it is if you isolate the x values, what we're doing is we're adding the 2 x values that we're given, and then dividing it by 2. So what we're doing is taking the average of the x values. Same goes with the y values. So the midpoint here is the averages of the x values and then the averages of the y values, and then put together as a point. And that is our midpoint between 2 points that we are given. Okay, so this example says find the coordinates of the midpoint M of the segment with endpoints -7, -5, and -2, 13. So just simply apply this midpoint formula here. And this is what we're going to get. So -7 plus -2, so -2 all over 2. Do the y values. -5 plus 13. Okay. And that there is equal to -9 over 2, comma 4. And there's our point. That is our midpoint for the 2 other points that we are given, or between the 2 other points that we're given. All right, let's apply this again in another example. Okay, so in this example, it says find the coordinates of the other endpoint Q of a segment with one endpoint at P 8, -20, and the midpoint M, that's at 4, -4. Well, for this one, we're going to apply that midpoint formula again. With the points that we do have, we're going to say Q is found at x, y. I'm going to use these 2 points and set it equal to this one right here. So 8 plus x over 2 and -20 plus y over 2 is equal to 4, -4. Now, whoops. Didn't mean to do that. Let's see. Equal to. All right, so what we do here is we break it down. We set this equal to our x value, this right here equal to our y, and we solve for our x and y. So we have 8x, or 8 plus x over 2 equals 4. And that gives us x is equal to 0. And then if you have questions how to solve that, let me know. I'll help you out in class. And then let's do the y value. -20 plus y over 2. Set that equal to -4. We get the y value of 12. So there we go. We found x is equal to 0, y is equal to 2. So our point Q is at 0, 12. There we go. Okay, the last few examples that I have for you here are finding order pair solutions of equations. What this is we're just going to plug in some value of x into our equation up here and find the y value for it. So I just picked random numbers here for x. You can pick any other numbers that you want on your handout there, and we're just going to find the y values for it. So plugging in -1 up for our x value up here, this is what we're going to do. So y is equal to negative 2, negative 1 plus 5, which equals negative 7. So for our x value that is negative 1, our y value is negative 7 for this equation that we have up here, our function. Okay, do the same thing for the next one. Plug in x of 1 and solve. There we go. And the last one, let's see, negative 2 times 3 plus 5. That is going to equal negative 1. So there we go. The three ordered pairs that we have are negative 1, negative 7, and 1, 3, and 3, negative 1. So these three ordered pairs are our solutions that we are looking for this particular example. Let's do this again. So similar thing we have here, except for this equation, we have x equal to something containing y. So what we have here are random y values that we're going to plug in. So here we go. I'm going to plug in negative 9, which equals, oh, that's a cube root, which equals cube root of negative 8, and that is negative 2. Do the same thing over again. Cube root of negative 2. And that's the cube root of negative 1, which is negative 1. And our last x value here, cube root of 7 plus 1, which is the cube root of 8. We know that is 2. All right, so writing it as ordered pair solutions, remember our x value still goes in the same place as the previous slide, but so we're going to write this as, here's our ordered pair solutions. Our negative 2 goes first because it's the x value, and then the y, negative 9. Negative 1, negative 2, 2, 7. And that's it for finding ordered pair solutions. So that's really all I have for you in this lesson, and I'll see you tomorrow or whenever the next class day is. Bye, everybody.